Hi everybody, in the video today we're going to take a look at an example of a second order ordinary differential equation. It's going to be homogeneous, which just means the right hand side is 0, and we have some constant coefficients. As we can see, the coefficients in front of each term are 1, 8 and 16. Okay, so the solution. Well, to solve equations of this form, we need to build an auxiliary function, which means replacing the second derivative with some quadratic term, first derivative with a linear term, and y's, let's just think about it as a 1. So in our case, we have m squared plus 8m plus 16 equals 0. This is the auxiliary equation. It's a quadratic. And to solve this differential equation, well, we need to solve this quadratic. So let's do that. How are we going to solve this one? We could factorize, complete the square, or use the formula. I think I'm going to complete the square just because I can see the coefficient of m is 8. Half of that, that's an even number, is 4. So if I multiply that out, I get m squared plus 8m, and the constant term, which isn't always right, but in this case it is, 16 equals 0. So it's a perfect square. So in our case, we have a repeated root of -4 to our auxiliary function. Okay, so to find the solution of our differential equation, we need to know this particular case. So if the auxiliary function has a repeated root, we need to know that the answer is going to be ax plus b e to the m1x, where m1 is the repeated root. If we know that, we can figure out the final answer very, very easy. The repeated root is -4. So final answer is y equals ax plus b e to the power -4x. And we can see this is the general solution. So any particular solution, and any one solution has this form, and the reason we know that, there are two constants and we're working with a second order differential equation, so that's what we expect to happen. So there you go, there's another example of solving these types of equations.